I'm Anil Kumar, and in this video we'll explore a sequence given recursive formula. Question here is, determine whether each recursive formula defines a geometric sequence where n belongs to natural numbers. Now I've taken a couple of videos and I'm considering one recursive formula at a time, right? So we'll do one at a time. So what we are given here is a formula which says t of 1 equals to 10, t of 2 is 20, and tn is 4 times t of n minus 2, where n is greater than 2. Now, in every recursive formula, you have to relate general term with the previous term. You'll notice here we are relating it with the previous but 1, right? So, n minus 2, okay? So, and n is greater than 2 because we know what is t1 and t2. So let us say these are the values for our terms. Let's say, I should write tn here. Tn equals to 4 times tn minus 2, and here we'll write n, the number of terms, right? So what we know here is that the first term is 10. So if n is 1, then we have t1 equals to 10. If n is 2, then t2 equals to 20. For 3, t3 is equals to, when you substitute the values, you get 4 times t of 3 minus 2, right? 3 minus 2, let me write first 3 minus 2, which is 4 times t of 3 minus 2 is 2. And what we find is 3 minus 2 is 2, which is 20. So it is 4 times 20, correct? So what do we get? We get 4 times 20 as 80. So that is the third term. Now what is the fourth term? So if I write 4 here, I get 4 times t of 4 minus 2. I did a mistake. It was n minus 2. So let me write n minus 2. So n minus 2 will be t1, and let me correct this. t1 is 10, and so this answer is 40. Okay, sorry for that mistake. Anyway, now we have corrected this, correct? Now t4 is 4 times n minus 2 it was. So 4 minus 2. So it is 4 times t, 4 minus 2 is 2. So t2 is 20. So we'll write 4 times 20, and what we get is 80. Fifth term for us will be t5, which is 4 times t5 minus 2, which is 4 times t3. t3 is 40 for us, so 4 times 40. That gives us 160. Sixth term is 4 times t6 minus 2, 4 times t4, 4 times. Fourth term is 80 for us, right? 8 times 4 is 320. Now the question is, determine whether each recursive formula defines a geometric sequence or not, right? So in this case, what do we observe? So the terms here are indeed, let me write here 10, then we have 20, 40, 80, 160, 320, and so on, right? So in each term, if I divide 20 by 10, what do I get? So if I do 20 divided by 10, I get 2, right? So if I divide, so the common ratio, if you find common ratio as same, then it means it is a geometric sequence, correct? So if you continue this pattern and divide, you get 2, right? Since the common ratio is constant, we say yes. It represents geometric sequence, right? Since our common ratio is 2, right? I should write common ratio between subsequent terms is constant, and it is 2. So that is how you can actually answer these questions. I hope that helps. Thank you, and all the best.